Hello dear students. Let's see what do you mean by cascadeless schedules. In the previous video, we saw what do you mean by cascading abort or cascading rollback. And we also got introduced to what is meant by cascadeless schedule. But I thought of making another video which will discuss cascadeless word in detail. Let's start with the definition, because I hope you have seen the previous video and you are already aware of what do you mean by cascadeless schedule. Anyway, just check. A cascadeless schedule is the one where each pair of transaction Ti and Tj. Let's see that there is a transaction Ti. Think of a transaction Ti and Tj. Some pair you have taken Ti and Tj such that Tj, this transaction Tj reads the data item that was written by Ti. So Ti may have read the data item A and written the data item A, and Tj is reading that data item A. Now check that Tj is reading data item A which was actually updated or written by Ti. Okay, that is written by Ti. Then commit operation of Ti must appear before read operation of Tj. That means before this read operation, commit operation of Ti must occur. If this is done, then we say such a schedule which contains each pair of transaction Ti and Tj in such a manner is called cascadeless schedule. To describe it more, just check here. We have drawn three transactions. You can see how T1 is updating the value of A and then commit is done by T1. So the changes made by T1 are now permanent. It says T1 is announcing that I will never roll back now, because the commit statement means that the changes are permanent and now it cannot be changed by T1. Just check these words. The changes cannot be reverted or rolled back by T1 because T1 has committed. And then T2 reads this value of A which was updated, which was updated by T1. And then T2 also updates the value of A, writes the value of A, but it commits. And after the commit statement, T3 reads that updated value which was updated by T2 is read after commit. If this happens, then the three transactions T1, T2, T3 are forming a schedule S which is known as cascadeless schedule. And what do you mean by cascading aborts? Just see, if this commit statement is after this read A, that means read A is reading this T2 is reading the value which was updated by T1 and commit occurs later. Then this may result, just check my words, this may result in cascading aborts. Similarly, the value written by T2 is read by T3, but T2 commits after read A. After this read A, T2 commits. Then this may result in cascading aborts, because if T1 fails, as we saw in the earlier video, before it commits, then it rolls back and the value read by T2 which was updated by T1 is now dirty. Similarly, value read by T3 is dirty. So these two transactions have to be rolled back, isn't it? But if every transaction Tj is reading the value which was updated by Ti, see, this updation was done by Ti, but Tj is reading the value of A only after commit, then such schedules are called as cascadeless. I hope you are understanding why these are cascadeless. Imagine that T1 starts running and it has updated the value of A, and just before it commits, here just before it commits, it fails. It fails. Then from here, from this point, it will be rolled back. But then hello, T2 need not be rolled back because T2 has not yet read that value. Note that this read A is after the commit, isn't it? And T1 has not yet committed. It failed before commit. So let it roll back. Let it roll back and restart again. But that won't affect T2. Similarly, that won't affect T3 either because T3 is reading authentic value from T2. T2 has committed and after that T3 is reading the value of A. Here is the question. Just check it. Suppose I have three transactions T1, T2, T3 and imagine T1 reads A, updates A. I hope you are understanding here there is some updation process like A is A minus 10. It is changing the value of A and then writing A. But there is no commit. And then T2 is reading value of B. Just notice this. T2 is reading the value of B and writing B. Now, hello, this will not affect anything because this is not yet a conflict at all. See that T1 has written the value of A and T2 is reading the value of B. So this read is allowed before even the commit is done of T1. But now just imagine there is read A here. Look at this. In T2 there is read A. Then before this read A, somewhere before the read A, commit must be there. In T1, commit must be there. That means whatever changes it has done to A are committed and now this read A is authentic read, isn't it? Same reasoning can be done for T3 also. Just imagine write A has been done here in T2 and T3 is trying to read the value of C. It can, although T2 has not yet committed. Observe, there is no commit statement here. But then this C can be read because T3 is reading some other data item and it is writing C. But now imagine T3 is also interested in reading A. Then before this read somewhere, commit must be there, isn't it? In T2. If this happens, then such schedules are known as cascadeless. Okay, this is what I have described over here. Just check that in the above schedule, it has been written. In the above schedule, the transaction T2 reads data item A only after commit operation of T1. Hence, the data item A read by T2 will always be correct, authentic, and it won't be dirty. Similarly, T3 reads data item A only after commit operation of T3. Hence, data item A read by T3 will always be correct, not dirty. In short, never read data item which was updated by uncommitted transaction. Just check this word. That means read data item only if commit has occurred in the other transaction and the other transaction has obviously modified that data. The above schedule is cascadeless schedule because if any transaction fails as we saw or roll back, this will not result in other transaction to roll back. Clearly, every cascadeless schedule is recoverable schedule. I'll come back to this point once we complete the topic. Trust me, I will revise what is recoverable schedule and what is the relation between recoverable schedule and cascadeless schedule. But remember, every cascadeless schedule is recoverable schedule, but vice versa is not true. So if we show a Venn diagram where this is all the set of recoverable schedules, then there is a small set which is cascadeless, and this cascadeless schedule is basically a recoverable schedule, but vice versa is not true. Trust me, I will come to this point once we complete this topic because there are two more types of schedules that we have to see which are related to cascadeless schedule. Thank you very much.